Magnetomotive force. Magnetomotive force, it is a driving force. Oh, by the way, no, magnetomotive force, this is represented by the variable tau. So it is the driving force required to drive a magnetic field to a magnetic circuit by passing an electric current through a number of turns and of wires. So basically speaking, again, no, you are going to make an electromagnet just like this one. No? So mo kag electromagnet, then of course, in this electromagnet, there will be magnetic flux flowing through your, let's say, core, and then course, it will develop a magnetic field. Then the force required the force required to make a magnetic field flow through the core is called magnetomotive force or MMF. Okay? So, kung wa gyapon kasabot na let me explain it this way. Magnetomotive force, again, no, force man na siya. So, ang magnetomotive force, pare-parehas na siya og voltage. 'Di ba ang voltage is electromotive force? 'Di ba ang voltage is siya man ang force para mo-move si current, para mo-move si electron. Now, ang magnetomotive force is siya ang force para mo-move ang imuhang flux. So therefore, naa-day ni siya ko ano kanang naa-day ni siya kanang connection sa electric circuits. Okay, so let me expound that further. Now, yun na, no? Ang ato adi ay magnetic circuits o electric circuits, they are synonymous. So, naa na sila so, murag ma-relate sa usag-usa. We have electric circuits and magnetic circuits. Okay? So, unsa may ma-relate na ito ha? Okay? Again, as I have said, di ba, magnetomotive force. So, tau. Magnetomotive force sa magnetic circuits, as I've said, mura na siya og voltage sa electric circuits. So, kung ang voltage is electromotive force, sa magnetic circuits kay magnetomotive force. So, this is EMF, while this is MMF. Okay? And then, again, no, force sa ang kaning magnetomotive force is force para mo-move ang flux. Okay? At ito sa electric circuits, ang voltage is force na siya para mo-move ang electrons making current flow. Okay? And then, of course, naanay resistance. Kung sa electric circuits na atay resistance, naasantay kapariha sa magnetic circuits. Kung resistance is it will resist the flow of current, you have reluctance sa magnetic circuits. Reluctance, it will resist the flow of flux. Don't worry, ikaw na to discuss ang magnetomotive force, i-discuss na to ang reluctance. So, mao ni ang kanang connection between electric circuits and magnetic circuits. Okay? So, if you have VIR for electric circuits, you also have magnetomotive force, flux, and reluctance on magnetic circuits. Okay? So, hopefully, you have understood now what is magnetomotive force. Okay? So, to determine the magnetomotive force, okay, you have to use the formula tau is equal to Ni in ampere terms, or you're going to use 0.4 pi Ni in Gilberts. Now, sa ng duha ka buok. Of course, kaning primero nga formula, this is the SI unit. Kaning ikaduha, kaning Gilberts, this is the CGS unit. Okay? Excuse me. So, mo gihapon ang atong magnetomotive force na gihapoy SI unit ug CGS unit. Okay? So, again, you have this formula. Then, as I've said before, you have reluctance. This is synonymous to resistance. So, reluctance, a property of a magnetic material to oppose the flux from penetrating the material. So, kung resistance to oppose the flow of current, ang imuha sang reluctance, i-oppose niya ang flow sa imuhang flux. Okay? So, to solve for the reluctance, you have the formula R is equal to the length divided by mu o mu R over area. Now, what is mu o mu R? Okay? Mu O is open space permeability or permittivity and mu r is the relative permittivity. So don't worry, I'm going to explain this later. Okay, I'm going to explain this further. Now, you have this, the relationship between flux, magnetomotive force, and the reluctance. There's also a similar relationship to Ohm's law. Okay? So that's why I've said nga, ang imuhang magnetomotive, may imuhang magnetic circuits o electric circuits, synonymous na sila. So since synonymous naman na sila, you can also apply Ohm's law to magnetic circuits. So again, I is equal to V over R. But for magnetic circuits, you will have flux is equal to the magnetomotive force divided by the reluctance. So in terms of SI units, your tau is Ni. But in terms of CGS, your tau is 0.45. So of course, flux in SI is Weber's, flux in CGS is Maxwell's. Okay, so ato nang i-apply sa example na rin. Example number 5. Circular ring. Here, so na lang itong solver. Number 5. A circular ring has a mean diameter of 20 centimeters and a cross-sectional area of 30 centimeters squared. It is wound with a coil of 1,200 turns. The ring contains an air gap 1 mm long. The iron has a permeability of 200. What current should be in the coil to produce a flux 1.5 times 10 to the power of 5 Maxwell's? Okay, so for this one, as you can see, circular ring na sad lagi ni siya. Pare-parehas ni sa katong gihatag na ko nga pre-finals ninyo, no? Naa say circular ring na sad. Sige, kuluringon. Wala, no? Sige lang. Circular ring siya, pero take note, naa siya air gap 1 mm long. So, let's say, kung front view, inani lang ako ang kuan ha. Yun ako pag-drawing. Kung front view, inani ang front view, for example, na this is your circular ring, you have here your air gap. Okay? Your air gap is 1 mm. Na. So, if the iron ko, no, take note na atay, has a mean diameter. Mean diameter of 20 centimeter, cross-sectional area of 30 centimeter squared, coil of 1,200 turns. You have the air gap and then permeability. So permeability of 200. Kanang permeability, that will be your mu r. Okay, the relative permeability. So that is mu r nimo is 200. Okay, what current ko no should be in the coil so that the flux will be 1.5 times 10 to the power of 5 Maxwell's. So as you can see here, ang atong flux is, ang atong flux sir in terms of CGS. Sige sir, saan mo naman ipag-solve? Na, solving for current. Saan mo ipag-solve sa current sir? Okay? Now, given our looking at our given, you have the flux, you have the mu r, you have the number of turns, the diameter. Sige sir, unsaon man na aron sir, unsa may buhaton na tuwa na aron. Okay? Now, sa may formula nga masolve na to ang current. So the only formula nga masolve na to ang current will be recall. Okay? Recall, magnetic flux density is equal to mu Ni over ito, the length. Ano day? Ano day, nalimot nilo. Ito kung gibutang na rin length ba to, diameter. The length day, length day kay kuhan pa man day ni kanang solenoid pa man day ni akong gibutang. Okay? Sige. So, you have Ni over length. Nya, naatay length, sir. Naatay N, sir. Naatay I. Okay? Na I is in question. Muna pangutana diha ron. Muna kailangan na to sulbon. Okay? Or, pwede sad, recall. Di ba? Naaman tayo bagong gidiscuss. Tau is equal to Ni or 0.4 pi Ni. How about ka na, sir? Okay, so looking back, uy, naamday tayo tao dahil, sir, no? So, you have to broaden your horizon sa unsa gani, unsa may mga formulas na ay. Okay? Sige, unsa may pwedeng, unsa may mas maayong gamiton? Yung kaning magnetic field density or kaning tau? Take note, you are given the flux. Okay? So, if na kay flux, ah, makuha ko no ang flux. Now, recall, balik na diri sa notes. Diba, pwede mo na ito magamitan ng Ohm's law. Flux is equal to tau over the reluctance. Pwede ra, tau na lang atong sulbon because if we can solve for tau, we can solve for tau using the formula from here, okay, from Ohm's law, should be flux times reluctance. So if masolve na ito ang tau, masolve diretso ang I. Okay? So, or CGS unit na I. Okay? So, kanina lang, kumpara sa arita na rin, no? Mag-solve pa taaning magnetic field density. So, na naman tayo flux daan, reluctance na lang atong solbon. Diba? Now, going sa reluctance. Okay? But, reluctance is equal to, going back to formula, length over mu o mu r over area. So, length over mu o mu r over area. Okay? Now, sir, kung naatay mu r nga 200, ito lang mu o. Mu o, that is open space permeability. Okay? So, kung naatay relative permeability sa iron nga to ang gigamit sa coil as atong ring, asa man sad ng open space permeability, sir? So, kanang mu o nimo, that is ang palibot sa imuhang coil as imuhang ring. Sa may palibot sa imuhang ring. Okay? So, there are times nga ang ring gi-immerse sa liquid, gi-immerse sa certain liquid nga na ay equivalent nga permeability. Okay? So there are times nga kung wala ra gisulti, wala sa ani nga problem, wala gisulti ra kung asa siya nahimutang ni nga ring. So it's safe to assume nga kani nga ring in open air na siya, in open environment ra na. Okay? So therefore, kung in open environment ra na, ang imuha dayong mu sub O is air. Okay? Now, take note, ang permeability ba sa air, you already have the standard. Ba? Now, for this one, okay? For this one, sa may itong sunbon na ni sir. Okay? Saan mo na ito pag-solve ni sir? Take note, we are given the flux in Maxwell's. Okay? Now, okay, Maxwell's naman lang na siya, then, let's solve na lang let's solve this problem na lang along, kanang CGS all the way. CGS na lang nato all the way kay Maxwell's man naghatag nga flux. Ya, naamon tay formula sa tau in terms of CGS. So CGS na lang. So therefore, okay? So therefore, you will have ang ato ang tau is 0.4 pi Ni is equal to ang flux na given times ang ato ang reluctance na length over mu o mu r times the area. Okay? So therefore, by the way, ato na ining klaruhon no kaning reluctance. So na ining klaruhon. Okay? So we cannot just directly use this. Na naman, it's because take note kung whole ring paunta ni siya, okay ra usaray reluctance niya. Unsa usaray reluctance sir, meaning duha din ni kabuk reluctance, tulo or unsa ba dili din ni usa lang? Answer to that is yes, dili ni usa lang ka reluctance. Nga naman, it's because ang reluctance sa iron sa imuhang ring is different sa reluctance sa imuhang air gap. Lahi man ang reluctance sa air gap, lahi man ang reluctance sa ring. Okay, take note na amantay air gap nga 1 mm long. Nya ang kaning permeability sa iron is of course applicable ra pud na sa iron ra pud nga pa. Diba? So igabot sa air gap dili na iron. So therefore igabot sa air gap air na siya. So you have to clarify ang atong adeng reluctance dere would be times reluctance sa air gap, okay, plus reluctance sa imuhang ring. Okay? So, kana siya dapat. So, duha ka mo itong solbon sa reluctance. Okay, pero don't worry, dali raman na. Okay? Again, si GS all the way ta, kay si GS man na to ang, kuan, ito ang flux. Yan, ato asang area. Okay, ato asang area, si GS po. Sige, so this will be 0.45 times, ang number of turns is 1,200. Okay, times ang current which is unknown is equal to ang flux, given ang flux na 1.5 times 10 to the power of 5 Maxwell's, times the excuse me, the reluctance. Okay? So the reluctance, let's start with the air gap. Ang length, recall, no? Reluctance is this one. Length. Length sa air gap. Ang length sa air gap is 1 mm. But take note, si GS unit man ta. So dapat i-convert na to ang 1 mm into si GS. So 1 mm times 1 centimeter is equivalent to 10 mm. Okay, cancel, cancel. Divided by open space permeability sa air gap. So unsa may palibot sa mong air gap? Air ra gihapon. Ya kay CGS man ta, recall, permeability for air in CGS is 1. Okay? Times, no, open space permeability. Times relative permeability sa air gap. Okay? Air man gihapon, so 1 ra gihapon. Okay? Times area. Okay? We already have a given cross-sectional area sa imuhang ring, sa imuhang kanig. So unsa man ang cross-sectional area, sir? Kanang kaning area, ana nga area. Ang iyahang cross-sectional area pasabutan na is ang inside sa imuhang ring, inside sa imuhang ring. For example, kung ako ni siyang putlon, let's say, no? Let's say, walang square like ni para ma-explain ako karon. Okay? For example, mao ni ang ato ang ring. For example, lang ha. Example, mao ni ato ang ring. Okay? So, ang cross-sectional area na pasabot is kani nga part. Muna pasabot niya sa cross-sectional area. Kani. Okay? Ang area sa imuhang inner. Okay, dili ang outside nga kani. Dili ka nga area. But ang area diri, kani nga part. Okay, kana nga part, ang area. So, ang area sa iyang solid nga part. Muna pasabot sa cross-sectional area. Okay? So, with that, unsa man sa area sa atong air gap. So, ang area sa atong air gap will be, of course, parehas ra sa area sa atong ring. Nga naman, inigagi sa flux sa air gap. Siyempre, kung unsay porma sa iyahang giagian sa ring, inigagi niya sa air gap, oras sa iyahang porma. Dili mausab, ang man ang ring, ang porma kay let's say square. Ang iyahang kanino, kanang iyahang gap, square ang end. Yang ang man sa ginigawa sa flux diya, mahimo ng circular og porma nila. Lisod sa gayo, balik niya so diri sa babaw, mubalik sa square, for example lang. So dili na pwede. So dapat kung sa imuhang cross-sectional area sa imuhang ring, igabot sa air gap, ang cross-sectional area sa imong air gap parehas ra gyapon. Lisod sa kay ang cross-sectional area sa imuhang ring kay square niya, ang cross-sectional area sa imuhang air gap kay circle. Hindi na pwede. Okay? So binuang sa gayo nagkalit. So therefore, ang atuadang area para sa air gap will be the same, which is given naman daan na 30 centimeters squared. And we don't need to convert this one because centimeters si GS man ito ang atong sulbon. So this will be 30. Uy, green man. This will be 30. Okay? Ano? Uy, napaday. Plus pa ni. Plus. Okay? Ang reluctance sa ring. So reluctance sa ring. Take note ha. Ito ni karuhon mo. Reluctance air gap. So ang length sa air gap. Okay? Divided by mu O sa air gap. Mu R sa air gap. O no, not length. Area sa air gap. Yung kani, mukhang reluctance sa ring, nato di ang length sa ring, divided by mu O sa ring, mu R sa ring, o area sa ring, cross-sectional area sa ring. So, ito nagklarohon ha. Therefore, not the plus. Sa may length sa ring, how do we get the length sa ring? So, usan niyo sa inyong sulbon sa inyong midterm, no? Midterm pre-5 ay pre-5. So, sa inyong sulbod sa inyong pre-fi, ang question ato kay, how much kuno ang diameter? So, saan man yung pag-solve sa diameter nga, magnetic field density man to. So, you need length. Now, sa may length sa circular nga ring. Ang length sa circular nga ring is, of course, ang yahang, ang yahang perimeter. So, take note, ang perimeter sa ring is 2 pi times the radius r. Pero, kana kung ang imuhang ring is complete circle. Take note na apa man kay air gap. So, i-minus nimo ang air gap pag yun. I-minus nimo kay naman na lahi man ang length sa air gap. So, therefore, for this one, 2 pi r minus ang length sa air gap, that is 1 mm, supposedly. Okay? So, if we're going to, wait. Sa may ito ang quadrant eh. Naabot tayo given diameter of 20 centimeters. So, for this one, 2 pi r mga to ang kuan, ang ito ang formula for the perimeter or basically, circumference sa imuhang circle. Okay? So, ato na lang din i-change. This would be 2 pi times 10 centimeters. Uy, anong zero ram ni? Minus ang length sa air gap. So, di na nato apilon ang length sa air gap. Kaya man ang reluctance sa air gap. Mo bitaw na, mag-isolve na to og lahi ang reluctance sa air gap. So, minus na to ang air gap. Excuse me. Walay appeal ang air gap sa length sa ring. This will be minus 1 mm. Yan, i-convert sa nato, you have 1 centimeter equivalent to 10 mm. Okay? Then, divided by, yeah. As usual, mu O, open space permeability, and so may palibot sa ibuhang ring. Area man na, so 1 times. Gihutoy mo lang ito, guys. Kita? Giahak na. Okay, then, continue ta, no? Namtay, ha? Ay,
Di
question?
ba ang given sa kaya ang diameter sir niya dili ra to ni divide og 2 para sa r sir.
Mao na nga ang gabantay mo ang radius nga kung gamit 10 kay ang diameter 20 man. Nakuha?
Sakto ni. Kuday. Binaog 10 may diameter.
Bantay mo good, okay? So bantay sad. Okay. So mo na nga gidiretso na lang na kog 10, wala na ako gipakita mga 20 over 2. Ayaw na, di na nato na ipakita ang 20 over 2, diretso na lang ta. Knowledge naman ta. Okay. So, continuing, ang mu r na to, so ang mu r would be, you have 200. This will be times 200 sa ring, times ang area, of course, area sa ring is 30. So, you will have this one. Mo na mo ang equation. Therefore, from this, masolve na mo ang current I. Okay, if we're going to solve for the current I, one day ko. Calculator, fx1. This will be, so again ha, 0.4 pi n ay itong gamit, it's because si GS man na to ang focus. Kaya to ang flux in Maxwell naman daan. So si GS na nataon din. Okay, so going back, we have point and times 1,200 times x equal to, we have 1.5 times 10 to the power of 5 times you have 1 over 10. Dito na kuha kay para makasave tag space ba. Divided by 30 ran eh. Then plus you have 2 pi and then 5 times 10 minus 1 over 10 minus 1 divided by 200 times 30. Yun na lang na po i-appeal ang 1 guys ha. Okay. So, so answer is 1.371. So this will be the current. Current is 1.371 37 to na lang. Yes. Okay? So hopefully, wala ko na sa iyo kung encode sa calculator. We have this answer. Okay? So nana ang nakitabo. Okay? So, mo ni siya, reluctance, magnetomotive force, then flux. So, again, this is called magnetic circuits. Mo ni siya kung ano, mo ni siya difference. So, yes, naagihapon siya, difference siya kay instead of current, flux atong gigamit, instead of voltage, magnetomotive force itong gamit, instead of resistance, reluctance itong gamit. Pero, it's just synonymous with electric circuits. So, ma-applyan gihapon nato og Ohm's law. Pag Ohm's law nga I is equal to V over R, this time atong gamiton is flux is equal to tau divided by the reluctance. So, dili untag ma-solve sa tanin, sample number 2. Okay? Pero, inig ko na lang ni inig face-to-face na lang ni. So, by Monday, we will continue discussing, I will continue solving this example problem number 6. So, same gyapon relate gyapon ani magnetomotive force, relate gyapon ani reluctance. Okay, so kaning problem number 6. Thank you very much for attending this meeting. Goodbye and